Hello and welcome to my video lesson 1.1b, which is the remainder and factor theorem when we're talking about factoring polynomials with a degree greater than 2. Alright, so we're going to look at degree 3 for the most part, but honestly this could work for any of them. It just takes more work. But we look at degree 3 so that we can look at more simple cases, and so it takes a little bit less time, but it's really the same process every single time. So the remainder theorem is saying p of x is the polynomial. If it's divided by the binomial x minus a, the remainder is given by p of a. So if we replace x with a, then that would be our answer. So we are actually going to do this with a calculator. I'm going to first plug in a, or figure out what a is. So just to start this, we make this binomial equal to 0, and then we solve for x, so in this case negative 3. And then we plug in that value of negative 3 into our polynomial, which is here in this case. So negative 3 cubed plus 2 times negative 3 squared minus 5 times negative 3 minus 6. Okay, and maybe let's give a little bit of extra space here to work with. So let's plug this into our calculator and see what we get. Negative 3 squared, cubed, plus 2 times bracket negative 3 squared minus 5 bracket negative 3 and then minus 6. And if that equals to 0, as we know, then that's the remainder, okay? So if the remainder equals 0, or sorry, not as we know, so if this part equals to 0, that means whatever that is our remainder. So in this case, the remainder is 0, which tells us what? Well, if the remainder is 0, it tells us that it is a factor. So yes, I'm giving it a check mark because it is a factor of that polynomial. Okay, I recommend pausing the video, trying out the rest of these three with that same polynomial, and seeing if any or all or some of those are factors. All right, let's take a look together. So same process, we're going to make it equal to 0, rearrange it, solve for x. So we can do that for each of them, but let's just do it one at a time. So p of negative 1 equals, and then we just put that negative 1 in place where all the x's were. Like that. And then we solve for that answer. So we're going to use our calculator. So it's the same exact thing, except wherever we saw a negative 3, we're going to replace it where there is a negative 1 in this case. And that should give us our answer. It's 0, so yes, this is also a factor. Okay, let's look at the next one. Hopefully you've already paused the video and tried it. So x equals 1. Now this is a positive 1, so we're going to put it in the same position. Oh, did I actually do that? Should be a negative 1 over here. Okay, so in the same position, p of 1 equals, and I think we can just go through and change this from positive to from negative to positive. So just deleting all of our negative 1s to just make them 1s. So So this gives us negative 8. So this has a remainder of negative 8, right? Which means that it's not a factor. Okay, looking at our last one, we're going to rearrange to solve for x. So that gives us positive 2. So the same process, putting in the 2 instead of x. So 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. P of 2 equals, and we're going to put it into this equation, but replacing all those 1s with 2s. So 2, 2, 2. And the remainder is 0, so yes, this is a factor. And you can hopefully notice this. If not, that's okay. Notice it now, please. If we have degree 3, okay, and we know 3 of the factors, we can actually say that those are the only factors. So to factor fully, if we actually have found 3, which in this case we have, those are the only factors of that polynomial, because it's degree 3 and we found 3, so that's how it is. It won't always work like that, but in this case it works. Okay, so let's now look at the next step. So factor theorem. If a remainder after dividing is 0, the binomial is a factor of the original polynomial. So then it's a factor. So that's what we just said. But now we can actually not just plug it in one at a time, but we can actually get some sweet information by plugging it in to our y equals spot. So we're going to plot it on our graph. So x cubed minus 13x minus 12. We're going to plot this on our graph, and you might be able to see it already just from our graph, but if you go second function and go for this table value, now you can see some spots. So where x is a number, y is 0. So wherever y is 0, those are our x intercepts, which are the same thing as saying zeros. Okay, so in this case we have x is negative 3, we have x is negative 1, and we have x is positive 4. So x is negative 3, negative 1, positive 4. But when we write it out as factoring, we have to flip the sign, because just like we had here, we had the opposites of how we would have actually wrote it. Opposites of like this part, which is the binomial that we're talking about. Same thing happens here. So we can go p of x equals, and we can go and say x plus 3, x plus 1, x minus 4. Those are our factors. Okay, this is pretty amazing stuff, but we're kind of doing one piece at a time. Let's take a look and see how we would actually do this in terms of problem solving. So what we would actually have is questions like this, where it says factor fully. And we're going to do 2 examples. I'm going to do the first one. You guys try the second one after you've seen it. And make sure you pause the video, try it out for yourself, and see if you can get it. Okay, so factor fully. So first step, step 1, is to, there's actually a little bit, there's one more little hint that you can find. You can look at the, sorry, I forgot to mention this. You can look at the constant term and notice that all of the values are actually factors of that constant term, which is kind of cool. So again here, 6, and we have negative 3, negative 1, and 2. Okay, so they're all factors of negative 6. So kind of interesting to notice. So that could be helpful, but I'm going to suggest step 1 is plug it in graphically. So this is to find as many of the zeros that you can without working at it. Okay? So let me show you what that looks like. So 2x cubed minus x squared. Whoops, that should be squared. Minus 5x minus 2. So we have graphically. So now if we go to the table, so second function table, just using whole numbers. So if you don't remember how to do that, second function window or table set, I make this one here, this number here, a 1. So anyways, now I can see that we have 2. So we know that, first of all, we have x, let's just make sure we get that, plus 1 and x minus 2. Okay, so we have those two values in here, but we know there's going to be another term. We don't know what that is exactly, but we know there's going to be another term. So now what we do is we take our step 2, which is to divide by one of the factors. Okay, so we know that we have two factors here, so we're going to divide by one of them. So let's just pick one at random. X plus 1 seems like it's the easiest to go with, so we're going to do that one, simply because it looks easy. Okay, so now we're going to go through and divide it. So x plus 1. I like long division. You can do whichever method you'd like, synthetic or long, it doesn't matter. So in this case we need to get it, so we have to multiply by 2. And we have to multiply by x squared in order to get it to x cubed. So now, in order to get rid of that first term. So we put that in, and then we get negative 3x squared down here, and 2x squared up top. Okay, now we put it back in, same kind of process here. X plus 1. This is going to go down a level regardless. Okay, and now we need to put in a negative 3. And one more x. Like that. So that leaves us with negative 2x, like this. And this will completely divide it out with a negative 2. Okay. So we have now divided by a factor and gotten a trinomial, or degree 2. So once we have degree 2, use PSA. Okay, now we can in this case even make it a little bit easier on ourselves because we already know one of the other factors, x minus 2. Okay, so when we're doing PSA to this question, okay, we already know that one of them is x minus 2. The other one we know is going to have a 2x here, so we just need to figure out the other part, which could be a minus or a plus, but let's figure this out. It'll have to be a plus, so that the constant term is negative 2, and it'll have to be a 1 to make that work. So you want to just double check everything, but yes, that works out. So that means our final answer will be this. All right. Hopefully this helped you out a little bit. Let's pause the video right now, try out this next question, and see if you can get it right. All right, hopefully at this point you've paused it, tried it out for yourself, because now we have two of our factors. Let's just see what they are. So x plus 3 and x minus 1. I'm just going to choose the easier one to work with, which I think is x minus 1. I just think that's a little bit easier to divide with. So we are now going to go on to step 2. And we're going to divide to try to find the binomial or trinomial part. So x minus 1. This is going to come down, this is going to come down. We're going to be left with this. Okay, so we're going to have to multiply by 3x squared, which gets us that. All right, and so now when we subtract, that first column disappears. This one goes into plus, so it's 10x squared. Okay, now what we need to do is kind of the same thing again, but we're going to get 10, so plus 10x squared, which so x, and then multiply that by -1, so negative 10x. This is going to go down, -3. First column will disappear, they cancel. The next one will go to a plus 3x. And then when you subtract, it'll be plus 3. And so when we multiply there, it'll get to -3, and that'll have a remainder of 0, which is good. We should have a remainder of 0. We already figured out it was a factor. So now what we're going to do is we're looking for this final term over here. So we can use that 3x squared plus 10x plus 3, and we need to find the PSA2 method to get the answer. So the first part, well, we know it's x plus 3 because we already know about that from up here, right? So the second part is going to have 3x because of this guy. We know it has to have 3x. And then it's all positive, so it's going to be positive. And this is a 3, so it's going to be 1. And then you just want to double check it, multiply it out, and yep, that all works out. You can double check it yourself, but our answer should be this guy. Alright, so I hope that this video helps you guys better understand remainder and factor theorem, and especially even how to factor fully. Good luck!